Hello, hello, we're back. It is Wednesday, April 28th, and this is your to-do list for the day. I picked my graphic on purpose today because today we are talking about rectangles. The first thing we're going to do though is we're going to back up and I'm going to go through some of the problems on the practice worksheet that was included in the lesson for Monday. The second thing we're going to do is we're going to talk about rectangles and their properties. And the third thing we will do is get some practice. All right, let's get started. There's not too much that I have to say about this first page of the practice problems. I felt like most of it was pretty self-explanatory or review. In problem number 1, do pay attention to which points are the midpoints of what segments, and remember that a midpoint splits a segment directly in half. In problem number 2, you're graphing the points and determining which type of quadrilateral it is. And to list the properties that you know to be true, you can go back through your notes or take a look at that quadrilateral org chart that I posted with Monday's assignment. Don't forget that the answer key to this practice worksheet was posted in the lesson tab for Monday, and you can check your work to these problems and the ones on the reverse side as well. What I'd like to spend time on is the second page, explaining how we can use the properties of these quadrilaterals that we're learning about to apply some algebra skills and solve for missing segment lengths and angle measures. In problem number 3, we're asked to find the perimeter of parallelogram ABCD. Since this figure is a parallelogram, we know that opposite sides must be congruent. So segment AB must equal 12 units and segment AD must have a length of 10 units. Since we know all 4 sides, all we have to do is add them together and we will find that the perimeter is 44 units. And of course, the property that we used is that opposite sides of a parallelogram are congruent. And so if CT is equal to a negative x plus 13, and AT is 4x minus 7, now we're working with one of the diagonals of this parallelogram. And we have another property of parallelograms that says the diagonals are going to bisect each other, which means they split each other into equal segments. So AT is actually the same length as CT, which means we can set those two expressions equal to each other. And so on the answer key, I go into detail of solving this equation, but in the end, you should find that x is equal to 4. Okay, and again, the property that we use is the fact that the diagonals of a parallelogram will bisect each other. And finally, we're given that the measure of angle CDA is equal to 60 degrees. So this entire angle right here is 60 degrees. We need to find the measure of angle CBA, this one up here, and also angle BAD, this one right here. So let's first start with angle CBA. In a parallelogram, opposite angles are going to be congruent to each other. This is one of the properties that we learned in this past lesson on Monday. So if the angle at D, angle CDA is 60 degrees, then its opposite angle, angle CBA, must also be 60 degrees. And we also know that consecutive angles in a parallelogram will be supplementary, okay? So that means that angle CBA and angle BAD are supplementary. Their measures add up to 180 degrees. So therefore, we can find the measure of angle BAD by taking 180 degrees minus the measure of angle CBA, which is 60 degrees, and so it's 120 degrees. In problem number 4, part A, we're told that the measure of angle XYZ is 95 degrees. And we're asked to find the measure of angle XWZ. Well, we have another property of kites that says the opposite angles on the short diagonal are going to be congruent to each other. We can even prove that by showing that this triangle and the one below it are congruent to each other. They would be congruent by side, side, side. And so another way to show that the angle at W and the angle at Y are congruent to each other is because of corresponding parts of congruent figures. Okay, so that means the measure of angle XWZ is also 95 degrees. In part B, we're told that the measure of angle WZY is equal to 110 degrees, and that the measure of angle WXY is equal to 40 degrees. And we're asked to find the measure of angle ZWX, which is this one right here. Okay, let me redraw that triangle for you up top there. And one property that we have of kites is that the longer diagonal bisects the two angles it connects. So if the full angle at Z is 110 degrees, then the top part right here is 55. And at vertex X, if the full angle is 40, then this angle is 20. And we can use triangle sum to help us figure out measure of angle ZWX, and that would be 105 degrees. In part C, we are told that the length of WZ is equal to 5, and the length of WT is equal to 4. They want us to find the length of ZT here. Well, the property that we're going to use to determine this is that the diagonals of a kite are perpendicular to each other. So triangle WZT is a right triangle. If we apply Pythagorean theorem, you'll find that that segment right there is 3. And if we also know that segment TX is 10, what would the perimeter of the kite be? Well, in order to find the perimeter of the kite, we would need to know what the length of side WX is. See, in a kite, consecutive sides are congruent to each other. So if WZ is 5, then segment ZY is also 5. If we know the length of segment WX, we'll also know the length of segment YX. And of course, right here, we have a right triangle. So again, we're applying the Pythagorean theorem. You'll find that X is 10.77, or segment WX is 10.77 using the Pythagorean theorem. So that means this side is 10.77 and the perimeter is equal to 41.54 units. Okay, so you can, I know I didn't write everything down for all the problems. That's done in the answer key that was posted for you on Monday, but I did want to go through and talk through with you some of the calculations and how I reasoned through those answers that were on the answer key. As I mentioned in the introduction of this video, today we're going to be talking about rectangles. The definition of a rectangle is a quadrilateral that has 4 right angles. Notice that the definition of a rectangle does not say anything about opposite sides being congruent or parallel to each other. Those are properties that we need to prove. And the way that we can easily prove those to be true is by showing that all rectangles are parallelograms. So this is what we're going to work on first. We have rectangle ABCD drawn for us, and we need to prove that ABCD is a parallelogram. So let's first talk through the proof and then we'll write it up together. Because ABCD is a rectangle, we know that we have 4 right angles. Now, to prove that a figure is a parallelogram, we need to show that opposite sides are parallel to each other. And we've said many times before, the easiest way for us to show that we have parallel lines is to start showing that some of the angle relationships that exist when lines are parallel hold true in the figure. Take a look at angle A and angle D. Both have measures of 90 degrees, and if I take the measure of angle A and add it to the measure of angle D, they add to 180 degrees. Angle A and angle D are supplementary angles, and if we take a look at their placement in the figure, they're also same side interior angles. When same side interior angles are supplementary, we know we have parallel lines and our figure is going to be considered a parallelogram. Now, technically, we need to show that both pairs of opposite sides are parallel to each other. So far, we've only talked through the fact that AB and DC are parallel because angles A and D both add up to 180 degrees. But we can easily follow the same line of reasoning for another pair of angles to show that segments AD and BC are parallel to each other. For example, we can use angle D and angle C to show us that because they would add up to 180 degrees as well. So when we write our proof, we're going to start with the fact that we're working with a rectangle. That is going to tell us 2 things, okay? 1, it's going to tell us that angle A and angle D are 90 degrees. And it's also going to tell us that angle D and angle C are both 90 degrees. So what I'm doing here is I'm creating 2 branches of my proof, and each branch is going to show that pairs of opposite sides are parallel to each other. A and D are going to show me that AB and DC are parallel to each other. So my next step is to show that they are supplementary. And now we need to do the same thing for angles D and C. I'm realizing that I forgot some reasons earlier on in my proof, so I'm going to back up just a minute here. For the bubble that says the measure of angle A and the measure of angle D are both 90 degrees, that's by the definition of a rectangle, okay? And so is the same bubble on the other side, that D and C are both 90 degrees. So these are by definition of a rectangle. Because it's a rectangle, we know that those angles are 90 degrees. And I'm also going to change my mind and adjust my reasoning for the last set of bubbles that I drew. Really, the reason why we're able to say A plus D equals 180 and D plus C equals 180 is just because we're adding numbers together. But really where we're going with this is both of these sets of angles, because they equal 180 degrees, are supplementary to each other. Perfect. I'm good with that now. Okay, so now that we've said that those pairs of angles are supplementary, now we can start to conclude that the opposite sides are parallel. And our reason for both of these new bubbles is that because we have same side interior angles supplementary, we know the lines are parallel. And finally, because we have opposite sides that are parallel, we know that ABCD must be a parallelogram. There were two other properties of rectangles I wanted to mention to you before we move on. I have run out of room on my notes to write them in the spot I had provided, so I'm going to switch colors here, and I'm going to put them over here in this box, okay? Maybe you write smaller than I do and you might have room on your sheet to write them in. But the first property is that the diagonals of a rectangle are congruent. And the second property is that the diagonals of a rectangle bisect each other. We are going to prove that the diagonals of a rectangle are congruent. So again, we have rectangle ABCD, and we're trying to prove that diagonal AC is congruent to diagonal DB. The way we're going to do this is with congruent triangles. I'm going to highlight the two triangles we're going to be working with. This one right here, ADC, and BDC. I want you to pause the video, see if you can figure out why those two triangles would be congruent to each other. If you have to, draw them separately. Okay, so we're back, and I drew the triangles separately so that we could talk through the proof. You should have figured out that the triangles are congruent by side, angle, side. First of all, they both have congruent right angles, so there's the angle that they share in common that's congruent. They also overlap at side DC, so we know that DC in this triangle is the same length as DC in the other triangle. Then if we take a look at segments AD and BC, they would also have to be congruent to each other. And the reason is because all rectangles are parallelograms, and all parallelograms have opposite sides that are congruent. So if the triangles are congruent to each other, then we know that the diagonals, which are sides AC and BD, those would have to be congruent to each other because corresponding parts of congruent figures are congruent. Let's write up that proof. Boy, I keep running out of room for my proofs. And there you have it. That's our proof showing that the diagonals of a rectangle are congruent. Okay, so what I'd like you to do now is pause the video and work through the next problem. You're given that you have a quadrilateral. Notice I did not say rectangle, but you know it's a quadrilateral, WXYZ is, and you're asked certain questions about it if you knew certain information. So take a few minutes, answer these questions, and then we'll come back together and check your work. Okay, the first question asks us if WX is equal to YZ, so we know these two sides are congruent to each other, and WZ is equal to XY. Are we guaranteed that WXYZ must be a rectangle? Justify your answer. Well, to be a rectangle, we need 4 right angles. What we know we have is opposite sides congruent to each other. Right now, we do not have any way of knowing that those angles are right angles. So no, we don't know that this is a rectangle if all we know is opposite sides are congruent. In problem 2, all we know is that the measure of angle WZY is equal to 90 degrees. So do we have a rectangle? If that's all we know, no, we don't know that we have a rectangle. We know nothing about the side lengths, and so we can't conclude that it's even a parallelogram. We have no idea what's going on with the other angles. So no, we still don't have enough information. So in number 3, it asks us, what if the information in problems 9 through 10 are both true? So we know that we have a right angle, and we know that opposite sides are congruent to each other. Do we have enough information now to know that it's a rectangle? And the answer is yes. If opposite sides are congruent, we know we have a parallelogram. That's a property of parallelograms. So if it's a parallelogram, then we also know that consecutive angles are supplementary, which means angle W must also be 90 degrees. And then angle X must be 90 degrees, and angle Y must be 90 degrees, because Z and W have to add up to 180, W and X have to add up to 180, and X and Y must add up to 180. So yes, this is enough information to show that we have a rectangle. And finally, if the information in problems 9 and 10 are both true, and WY is equal to 15, and WZ is equal to 9, and don't forget, that's a right angle, what would the perimeter of that quadrilateral be? Well, we know that the opposite sides are congruent, so that also has to be 9. If this triangle right here is a right triangle, we can use Pythagorean theorem to figure out the length of side ZY. So this side is 12, which means the one opposite has a length of 12, and my perimeter is the sum of all of those sides added together, which is 42 units. In the tab for today's lesson, I attached a practice worksheet that is titled Classifying Quadrilaterals. And so what this worksheet does is the first set of problems gives you a figure with a set of characteristics either marked or written in the figure, and you have to decide the most specific name for that quadrilateral, okay? So for example, number 6 here, okay, that figure is marked with 4 congruent sides. We don't know anything about the angles, so the most specific name I could give this is a rhombus. On the second page, you're asked to state all possible names for a figure. So the difference with this type of problem is we're not only naming its most specific name, but we're also stating all the other types of figures that it could be. So for example, in number 13, looking at the markings, we have opposite sides congruent, actually 4 sides congruent and 4 right angles. By definition, that makes this a square, which is the most specific name we could give it. But because we have 4 right angles, it's also considered a rectangle. Because it has 4 congruent sides, we could also call this a rhombus. Because we have, there's lots of different reasons for this next one, but we could also call this a parallelogram. The angles all being right angles means we have consecutive angles supplementary, so opposite sides are parallel. So this is also a parallelogram. And because it has 4 sides, it's a quadrilateral. Okay, so Think about that org chart that I posted in Monday's lesson for you. The farther down the flow chart we go, the more specific of a name we're giving these quadrilaterals. So that's what the first set of directions is asking you to figure out. Based on the markings, how far down that org chart could you go with this figure? And that's the answer they're looking for. The second set of questions is saying, all right, what's the most specific thing it could be, but then everything above it, it fits into that category too. All of the least specific names or less specific names that we can give that quadrilateral. These problems are not going to be collected. All of this information is in a resources tab. For Friday, you'll have an assignment for me that will be collected. But this is good practice for you to become familiar with the properties of these quadrilaterals. So I highly recommend you work through this. And on the last 2 pages of the document are the answers, so you can check your work. I've also included the Google form for questions for this week, so you can type in a question there if you have one, or you can also fill out your question, write your question on the geometry parking lot if you want to do that, and I'll look in both places, okay? Don't forget that I have a student support session scheduled on Wednesday for geometry at 1 p.m. and also on Thursday at 11 a.m. So please come to those support sessions if you're having troubles with the material. All right, good luck, and be looking for that assignment from me to be posted either late Wednesday night or early Thursday morning, and that would be due at the end of the day on Friday. Have a good weekend.